Alright. Internet speed's not doing too well. I'm just gonna stream music and try to work on this. So, uh, I think doing coffee on every Monday created a Pavlovian response that injected me with adrenaline the day before Monday, which caused my no work day on Sunday to leak into Monday, and I ended up watching movies on Netflix for like 24 hours straight. And so by the time Monday rolled around, I needed to go to sleep. And even though Monday had rolled around and like, oh, it's my coffee day, well, I don't want to be sleep deprived and inject myself with coffee. Like, I want to be fully rested and also have coffee. Otherwise, I'm just wasting my energy, right? My brain needs to be intact, and then my body needs to be intact before I like use coffee. So moved it to Tuesday, and I'm thinking that what I'm gonna do in the future to prevent this from happening is maybe every Monday I'll flip a coin, and if that coin is heads up, then I'll drink coffee. Like heads up, because like you're thinking like it's your face, and the head is where you drink the coffee, right? That's where you put the coffee. You put the coffee in your head, right? So if it's heads up, I drink coffee on Monday. If it's not heads up, we wait till Tuesday. We flip another coin. If it's heads up, drink coffee, and we just keep on doing that until it's time to drink coffee. And if it happens to where we just keep on getting tails, we just don't drink any coffee. And if it doesn't accumulate, so let's say we get the odd situation where we keep on getting tails for like 20 in a row and that leaks into multiple weeks, we're just gonna keep on flipping until we get to drink coffee. And then once we've drank the coffee, we don't start flipping coins again until we hit Monday again, right? So there's the potential that, let's say something ridiculous, like, for a whole year you keep on flipping coins, and then eventually you get to drink your coffee. It doesn't matter. You just do that every day until it finally hits heads. Once it hits heads, then you don't do that process again until the next Monday. So if that process had happened on, say, Sunday, right, it rolled over into multiple weeks and it finally happened on Sunday, then you would be able to drink coffee, do the same thing on Monday, right, and potentially have a cup of coffee on Sunday and a cup of coffee on Monday, if you wanted to. Otherwise, you could forgo it and wait till the next Monday. So, in general, we want a pattern where we can, when there's these outlier scenarios, sometimes we're going to end up drinking 2 cups of coffee, right? 1 cup one day, and then 1 cup the next day. But we want to make sure that whenever situations like that happen, we probably want to err on the side of cutting back rather than taking advantage of that. So when I do get that situation where I can drink a cup of coffee one day and can drink a cup of coffee the next day, what I might want to do is just forgo that next cup of coffee and wait a whole week, right? So when things get into these weird outlier situations, we might want to err on the side of consuming less rather than consuming more, even though the rules that we've set forth for ourselves say that we're allowed to consume this outlier of more coffee than usual. Okay, so I see somebody just pop by. I don't know how good my internet is, but I'm just going to start listening to music and start coding. And I was just talking about yesterday was Monday, and that was coffee day, but because I keep on consuming coffee every Monday, I think I had a Pavlovian adrenaline response to that on Sunday, which kept me up until Monday, and then I was already sleep deprived when Monday rolled around. I'm not going to drink coffee and try to work while I'm sleep deprived, because I want my mind to be fully recharged and ready to go, and then drink coffee on top of that, right? I don't want coffee to be this band-aid. I want it to like super accelerate my abilities. So that kind of sucked yesterday. So now it's Tuesday, and I'm just drank some coffee and I'm ready to go. Tuesday is coffee day for today. Also, I don't know who's stopped by, but if you want to check out my technical demos that I'm using for the basis of the engine, here they are. So I don't know how good this stream is coming in. So I'm thinking of just streaming some music and coding, and if there's some part that I feel that is absolutely vital to explain, I will explain it. But if you want to see the archives of what I'm doing, I have a list on YouTube. So, hold on. So there's a list on YouTube. I put that in the chat where you can see the archive of all the videos for the code I'm working on. And if you want to see the actual code I'm working on, I have it on GitHub. I only put the stable versions on GitHub on the public repo. So the public repo, let me, let's see. Oh, that's the wrong one. So I think it should be, I think this should be it. Let me actually check that for a second. Let me open up another tab here, see if that is correct. Yeah, so that's correct. That's the public repo is kanjicoder AAC 2020.git. We're working on a 2.5D rendering engine that is fractal based. There's a lot of things that go into it, but the basic is fractal auto tiling using 2.5D, merging together normal maps and doing a whole bunch of weird tricks to just get really high definition graphics with the least amount of artist input, so that we can really, it's not because we don't want to pay our artists, it's that we want our artists to be super efficient, and also we don't want our artists to have to work too hard to make something that's awesome, right? We want it to actually be really fun to make art with this engine. So we're really thinking about how we're going to get art into the game, because no matter how good your rendering engine is, if you can't get art into it, it doesn't matter, right? Like, you take every rendering engine there is and don't put any assets in it, and then all rendering engines are equal, right? It's just a black screen, right? So no matter how good your engine is, without quality art, it's nothing. So, but yeah, today I'm just gonna focus on coding this, and it's not gonna be much of a talky kind of day, but with that, I'm just gonna, put this up. Today is a boring day, ask me anything. And yeah, you can ask me anything. I will respond in the chat. So, and yeah, that's it. And I'm not even sure if my internet is good enough to, I don't know. Just today is kind of like a, can you link the YouTube channel? Oh yeah, I can link that. So the YouTube URL, let me, YouTube, Twitch. So it's everything that I've been working on. The whole time I've been working on this code base, or most of the time that I've been working on this code base, except for at the very beginning of it, I've been recording in the commentary of the code base. A lot of times you're going to see this. You're going to see something like @vid_iid, and then the video ID, and then the time with like a timestamp. So hours, minutes, and seconds. So a lot of times in commentary, in the code base, you will see something like this. And so the idea is the code base, like, since I'm recording everything that I'm doing, right, it's like, 6-hour recordings usually, almost every day. Nobody has time to watch all of that, right? I don't even have time to watch all that. So what I'm trying to do is I'm trying to make that, this stream kind of help help be supplementary documentation, right? Where if you're ever confused as to like what the hell was I thinking when I coded this, hopefully there'll be like a video ID timestamp, so you can actually go back to the original video where I recorded it, right? So I don't do it everywhere, but I try to do it in a lot of spots. Like, oh, actually, if you look at my code right here, so right here you can see that when I started coding this, at video number 75 at 2 hours, 20 minutes, and 40 seconds, I'm explaining what's going on here. And so if this commentary doesn't make enough sense, and you want the actual full thought process, you can go over here and you can actually find it. And if you look at the stream, the actual Twitch stream, the bottom right-hand corner, we can see the day is Tuesday in blue. The day is Tuesday. The integer ID for this video is number 76. Right, so that's how you can tell what video it is, and then it's labeled that same thing in the YouTube list. So you can actually go to the video numbered 76 and find timestamps. Or maybe a better example would be this, right? Video number 75, so we can actually go to video 75 in the list. I haven't uploaded video 75. I still have like videos 72 to 75 to upload onto YouTube. Interesting. Good idea to write comments for the time. Yeah, exactly. Like, I didn't want it to just be this pit of stuff that I'd never look at. Grayson Dexman, I don't know if I'm pronouncing that correctly. And also here, let me, since you're chatting with me here, let me change this for a second. So I can't really, my chat box kind of sucks here. But the idea is the primary purpose of this stream is to document the code. And so if you notice, I have a very small column limit here. You see how this blue line here doesn't go very far on each one of my monitors. It's only 60. Oh, language. This is C99/C11. So mostly I pretend it's C99. And then I use certain C11 features, such as the restrict keyword. And I think I'm going to try to stay away from multi-threading, just because you get a lot of very weird problems with multi-threading. Let's say you have like a Windows thread, and then you have a game logic thread, and you have a callback in your window to call some code, depending on what key you press. And the key you press is like a set bomb key, right, in your game. And then you think you have everything working all right because you have your window thread and then you have your game thread, and you're not supposed to mix them together. But that callback wired to the keyboard that's wired to the window code, that means that any of those callbacks are actually executing your game code in the window thread. And so there's a lot of points at which, you know, you're trying to multi-thread and you're trying to like separate everything cleanly, and you're going to accidentally make some mistakes where you're not going to. So does it not work with multi-thread because it's a very old version of the C language? So actually, C11 is the first spec with proper atomics. So yeah, C11 is the first spec with proper atomics. Now, I believe you could do multi-threading with C99. It just wasn't, there just wasn't a proper official spec for multi-threading. The reason I'm not doing multi-threading is because I'm just not that badass. Plain and simple, right? Like, I don't want to do anything that I can't handle, right? We want to keep things as simple as possible. And if I'm not ready to do multi-threading, it's better to have it written single-threaded without any problems than to bite off more than I can chew. So in my project, I actually do have a flag to multi-thread it, but if you don't do multi-threading correctly, you can have cache coherency problems, and instructions will also execute out of order. The order of execution is always kind of out of order, but But yeah, yes, it is a hassle to multi-thread. You really need to understand what you're doing to multi-thread. Just because I can actually find a video for you on, I think it's called Weapons of... It's not called Weapons of Mass Destruction, but it's like, it's a pun on that. Let me kind of look and see if I can find it. Weapons of Mass Destruction multi-threading. I don't know if this will find it, and also this isn't the right browser, but I'm gonna search in my shortcuts really quick for you. Mass weapons. Okay, I'm gonna just search for. Oh god, this might take a while. I'm looking around for you. Ooh, I think I found it. Channel 9, MSDN.com, Going Deep, C++ and Beyond, Herb Sutter, Atomic Weapons of... Yeah, found it. I can't believe that I found it like that. So let me take this, because I just found it, and it's kind of like... It's indirect, but I should be able to dig up the actual video. It's a two-part thing. Atomic weapons. Okay, like, see, like, it's a little joke, basically. But atomic, they're talking about atomics. They're talking about mutexes, semaphores, and fences. I guess barriers as well. I'm not really versed on that, but that's what they're talking about. Here, I'll just send this, because you should be able to find both videos from here, but these are, like, really interesting. It's really things that people, if you're not doing multi-threading, you don't have to worry about it, but if you do, you got to worry about it. So modern-day computers, the way they execute instructions is kind of dirty, right? They have, like, branch prediction, where you'll predict both branches of an if statement, and then once the instruction pointer kind of catches up to that branch, it will throw away one of those branches, right? So it'll like try to calculate a whole bunch of things ahead of time, and then just throw away the instructions it doesn't need. And also instructions will execute out of order on the processor. And usually that doesn't create any problems unless you have multi-threading, right? So the order of execution, right? Like when you have, when you write code, you're forced to write your code in a linear order. Like there's always a enforced linear narrative to how you write your code, but sometimes two statements, they don't depend on each other. So the processor can execute them out of order in order that might be more efficient. And usually on one thread, that's not a problem. But the problem happens when the order of execution doesn't matter when you look at a single thread, but when you look at the other threads that are depending on it, then the order matters. But yeah, you can take a look at that. That's going to be pretty interesting. But for right now, I mean, I guess, you know, I could explain... Have you seen this code base of mine before? Because I can explain the basic overview of what's going on here. But other than that, I'm not sure if I have anything interesting to say right now. It's just, right, I'm on, like, part 9 of trying to get this PAINT5D system working. So I'm on, like, part 9 of a sprint. I kind of bit off more than I can chew. I'm trying to take up a whole bunch of loose ends here. Here, I'll just go over the basic project really quick. The basic kind of organizational... Okay, yeah, so I'll go over the basic organization of this project for you, and then I'll show you some of the tech that I'm working on, or the old game, to show you kind of like what I'm working towards. So first of all, I'm trying to keep everything as flat as possible, so most of the sub-libraries are all in one folder. You'll see that a lot of things have .d and then .f, and what I'm doing here is I'm separating all of my code into data and functions. So every single library has a data file, which is just all the variables, and then it has a function file. The reason I'm separating it like this is because functions depend on data, but data does not depend on functions. And by separating everything into either a data file and a function file, I can avoid some artificial dependencies. When you use classes, a lot of times you tightly couple, I always pronounce it improperly, you tightly couple data and functions when you use classes, and you end up with what I call an artificial dependency loop. Say class A references class B, and class B references class A. Well, you have a dependency loop. You got a problem, right? But you might not actually have a problem. You might have an artificial dependency loop. Because what's really happening probably is a function in class A uses the data in class B. Okay, and then in class B, a function in class B uses the data in class A. So if you include A's data, then you include B's data, and then you include A's functions, and then you include B's functions, then you don't have a dependency loop anymore because you've cleanly divided where your data was and where your functions are. So another thing I'm doing that's kind of unique in this project. Yes, exactly. It's easier to separate them to remove these dependencies. So let's look at my project structures. This is kind of weird, but you see this big long list? This is all of the libraries that make up the project at this point in time. And if you're familiar with, they were introduced in C++ because C doesn't have them, right? Yeah, so C does not have classes. However, OOP, object orientation, is actually just a design pattern, right? So it's called, you can use, OOP is just object OOP is just a design pattern. OOP is just a design pattern, and if you want to do OOP in C, you can. But the way you do OOP in C, if you need to, which I will at some points if I think that it makes sense for the current sublibrary I'm working on, is it's usually like some member or function. So you would have like a self arg1, arg2. So if you want to do OOP in C, you would have something like this, right? You'd have like some member function, then you'd have a pointer to the self, and then you'd have arg1 and arg2. So in C++, what you're really doing behind the scenes is you're implicitly passing a self argument as this parameter that it's being implicitly passed. So a lot of things in C++ are syntactic sugar. Also, if you think about passing by reference in C++, you can pass by reference in C, but you just don't have the syntactic sugar for it. So a pass by reference in C is just passing a double pointer to something, and that double pointer has two criterias. The outermost reference can never be null, and that reference can never be reassigned. So if I wanted to pass something by reference, let's actually search the code base really quick for, I use like the by ref in some places to say that I'm passing by reference. And let's find in files really quick. I can show you what I'm talking about. Here we go. So this is kind of like ugly code. Can I find anything that's not as ugly? Oh, this is kind of less ugly. It's still kind of ugly. So what I do is, by convention, I just kind of like, in my C code, I say by ref right here. And then you see I have one of the pointer symbols here, and then I have one of the pointer symbols here. So I want to say that, oh, it's a pointer to an unsigned integer. So this is an unsigned integer array, but it's a reference to an unsigned integer array. And then for this backup thing, we want to make sure that the reference can never be null. And so you see this like void pointer 0 here. That's just the null keyword usually evaluates to this, right? Null just means it's a void pointer that's casted to 0. Or sorry, it's 0. Sorry, it's 0 casted to a void pointer. Now, you probably could get away in your code just saying that null is the number 0. You probably could get away with that. But if you actually look in the header files for where null is defined in your C code, and most likely in the C++ code as well, you'll probably find this definition of null. That's actually what it is. Okay, so let's show... Yeah, I know. It's pretty interesting, isn't it? Yeah, there's just a whole bunch of little kind of trivia you pick up as you've been coding for a while. You know, I don't know if it's actually helpful or not, like in terms of understanding code, but you know, obviously it makes you sound smart when you know all this trivia, so I guess it probably will help you in like interviews maybe. But I don't know how useful it is, right? So a lot of times I will hard code null like this if I have enough space to actually hard code it. Yeah, go ahead. Shoot, what are you into? What is it? Why write C99? Okay, yeah. So why do C99? So I'll give you the answer. So once upon a time, I spent 2 years making a code base in Flash. Let me go show you that. And I am getting to your point. And I'm getting to it in a long-handed way, but it took me a long time to decide on C99, so I think it's kind of fair. So let's do AA2 GIFs really quick. Or not AA2, AA1 GIFs. I'm going to show you some stuff from the old game. So let's see, GIFs in Windows Slideshow. I'm going to pull these up for you. And then I'm going to start talking. I'm not going to explain what this game does. I'm just going to show you it here. And then start talking about the C99 question. So, why C99? Well, it takes a long time to code a game. It takes a lot of time to just code stuff in general, right? And the last thing I want is to have worked on a code base for like 5 years, and then to have that code be completely worthless because the language I coded in it no longer exists. C has been around since my grandpa coded in C, okay? So C has been around forever. And you got to think, well, how are you going to pick a language that's going to be around forever? Well, one thing that can also determine stability, besides already have been around for 30 years, is, well, what else depends on C code? Well, how about Python? A lot of the machine learning libraries, the code is actually written in C. Some of it's C++, I'm sure, but a lot of it's written in C. And when you're doing machine learning in Python, you're just using Python as an interface to call these C libraries that are doing all of the real heavy lifting. When you think of Java, how about Java, right? Java is pretty popular right now. Well, what do you think Java is written in? Java is written in C and C++. So what does that mean if these different languages are written in C? What that means is for C to die, for C to actually die, Java has to die, Python has to die, a lot of things need to die. Probably like the Chrome browser, it's a Java virtual machine. It's the actual thing that runs Java. That's written in C and C++, so that has to die, right? So you have all these technologies that depend on C. And so they have to all die before C is going to die. So what I'm doing is I'm trying to pick something that's actually stable. And now, it is a lot slower to write in C than it is to write in a lot of other languages. So I'm trading development time for power, right? So you can have something that's really fast to develop in, like JavaScript, but it's not going to be as powerful when it executes, right? But you can prototype really quick. For something like C, it's the other side of that. So it takes a long time to develop, but when you start running it, it just runs blazingly fast. With that, I think you should at least have 2 programming languages you like to use. You should have one programming language you like to use that you can develop really fast in, and then you want another programming language that just runs really fast. So those 2 programming languages for me are JavaScript and C, right? When I want to prototype something really quick, I'll use like JavaScript and WebGL. Oh, I got it. So your games will still be compatible long into the future, even if now popular languages die. Yes, exactly. That is exactly the point. And it took me a long time. I tried some stuff in Golang. What else did I try? I tried JavaScript and WebGL. What else did I try? I did some C++. I messed around with C++. The reason I don't do C++ is because C++ is very complicated, and I already write very complicated code, and I don't want the language to give me all the ability to make it super complex, right? Like, I already have this problem, and I know I have this problem, right? I have this problem where I make code too complicated. I over-engineer things. So to avoid that, I want to use kind of a very simple language that's going to help prevent me from making things too complicated. And so C kind of does that, right? Because it can be such a pain in the ass to do something in an unnecessary, complicated way. So it kind of keeps you writing code a little bit more simpler. What else? So yeah, you're seeing this engine, and if you're familiar with like Bomberman, I think Bomberman is a very old game by now. The basic premise of this is it's basically a side-scroller Bomberman, except different bombs blow up in different directions, right? So there's vertical bombs, there's horizontal bombs, there's four-way bombs, and then there's instant kill bombs. So you see these bombs at the top, they're like little four-way bombs, and the skulls are like these big four-ways. And you can use these bomb types to create these chain reactions. Different materials have different properties. So some materials are invincible, meaning they aren't destroyed by bombs. The blue vent material you're seeing, it's indestructible, but it allows the flames to pass through it, right? That's why it's like this vent material. So the actual geometry of the level made with the vents won't break, but you can still get hit by flames from it. So you can't like hide behind the vents, because the flames will get you. Other materials, let's find a different material besides these vents. So this kind of viney material will just break and leave behind nothing. So you can see like right over here on this side, those bombs kind of like blew it up. And over here we're going to blow open this part of the level with the bomb so that you can kind of get through there, right? So boom, that part open and you can get through. So right here you see we had this straight path, right? But then the bombs kind of cut through the geometry and made it a little bit harder to pass through, right? Because it looks like this easy level, and then we break it open, and now you can fall into this pit of death right here. So a lot of like little cool things where you can mess with the materials. So right here, the bombs, these horizontal bombs, blow open that dirt, right? So you can just chain together very complicated explosions and make these kind of like Rube Goldberg kind of things. Yeah, the problem with this engine, though, we did it in Flash. Flash is obviously dead now. And it's also done in this, like, pixel art style, which creates a problem where if you want to, like, zoom in on these levels, you lose resolution. So we're working on an engine where you can zoom in and not lose resolution. The way we're going to do that is use a 2.5D rendering system. And let's go into the, I mean, you already probably, if you already took a look at my demos page, you've probably already seen this stuff, but I can kind of explain it a little bit more for you. So, so obviously you've already kind of seen this GIF here, but let's go take a look at this page. Actually, let me go change the screen here. So, right, so this tile engine here, right, it's an auto-tiling engine, but it doesn't use sprites, right? It's a, this is kind of what I'm talking about, 2.5D. It's kind of vector-ish in a sense, because you can zoom into it and not lose resolution, but there's also this 2.5D aspect where we could get some really cool 3D effects for these tiles, but we're not rendering with sprites, but we're not rendering with polygons either, right? We're doing this kind of thing in between. It's not 2D, but it's not 3D. It's 2.5D. So let's set some different tile. This tile is not that interesting. So we have these different tiles. Oh yeah. Yeah, I'm sorry. Yeah. Yeah, I can go back to that really quick for you. So different materials, different properties. So if we go back to the vines, right, so these vine materials right here, when they get hit by an explosion, they just leave nothing behind. So you can see kind of like when the bombs get that bridge, the bombs kind of blow up this bridge and make it harder to cross than it would otherwise be. Not all materials react the same way. So the vent material right here that you see, it is indestructible, but it allows the flames to pass through. So you can't hide behind vents to hide from an explosion, because the explosion goes through the vents. Now there's another material, it's like this, I think we call it like Dragonite. It's this purple material that we haven't really used in many levels. I don't really have a screenshot of it. Let me actually find one of Josh's levels for you to find that material really quick. Let's see if we can still go to Newgrounds and look up the game even though Flash is kind of dead. I don't know if my browser will... I don't know if my browser is blocking Flash now. But let's go back to that and see if we can find the old game and see if we can actually get to it or what happens. I'll actually send you a link to the game as well once I get to it, so you can check that out as well. But yeah, sorry, I've been having internet trouble. I need to get like a Ethernet cable to this, because like I'm down in the basement, so I kind of get screwed over with internet speed. So we're going to enable Flash Player. We're going to allow this. Alright, nice. So let's see if we can... let's see, NG full screen. Let's full screen this. Second... So I have a little lock on the game here to make sure that people read the seizure warning, and then second, third, and fifth is randomly generated, so you have to click the right boxes. Yeah, no problem. Yeah, like check in. Yeah, I mean, so also, like, if you ever want an explanation, like you don't understand a piece of code, like if it's not related to my stream, but it's a code question, just drop a question, and I'll see if I can answer it. Yeah. Yeah. Like it. Yeah. If, yeah. See you later. But yeah, if you have any questions that you have about programming in general, just drop them my way, and I'll see if I can answer them. I also can create, like, little code snippets for you as well. Yeah, you too. Like, have fun with it. I know, like, programming degrees can be kind of annoying. Like, it's not the, don't get disenchanted when your programming classes suck, because a lot of times your teachers will teach things in a way that is just horrible and stupid, and try not to get disenchanted if your class just sucks, because I'll tell you, like, Java, I fucking hate Java, and a lot of times your programming classes will use Java. So, like, try not to use your experience in class to kind of, like, judge programming, because a lot of times it's taught in just a horrible, horrible way. But I'll see you around. All right. Anyways, let's get to coding. And we'll kind of like today's still gonna be kind of boring day. But yeah, anyone can ask me anything. Otherwise, I'm just going to try to get some of this stuff working here. It's not going to be too interesting today. So, if you feel like going, that's perfectly okay. Also, my internet isn't working too well. I'm going to try to stream some Mega Man X music while we work on this. If there's anything I feel like explaining, I'll kind of mute the music and explain it. The reason I'll mute the music completely is because I don't want a copyright strike to mute out any vital explanations. So, with that, let's just try to get to it and get through today. I am totally lost right now, because it's been a few days since I was looking at this, but we'll try to get back into it, figure out where we got to go next. It looks like we have these unit tests. So UTC right here stands for unit test code. And the reason I use an abbreviation here is just because these function names just got really long, right? So everything in my code base is usually prefixed with AAC 2020, which is the project name. Then it has a second namespace, which is the sublibrary. So this sublibrary is called PAINT5D, and you can see PAINT5D up in this tab here. UTC, unit test code, so this is being called by a unit test. And what we're testing here is move camera XY. And we can see that we have some compiler directives here to just throw errors, right? Because we have to finish this test, we have to finish this test, we got to finish all these tests before we can get the code working. And then once these tests are done, we're still going to have a lot of work ahead of ourselves because we haven't written the GLSL shader code to properly render all of this stuff. So that's going to kind of suck. But hopefully once we get PAINT5D working, we're going to have this like awesome... It's going to be kind of like MS Paint, except it's hard-coded to have multiple pixel sizes, you could say. I'm going to call them tile sizes, but it's just going to look like you have these like different pixel sizes. And actually let's go to an old prototype I wrote to kind of see what this editor is going to look like. I wrote a prototype in Golang, and I can show you what that looks like and what to kind of expect. So let's, and this, we're also going to incorporate this kind of tech as well. So you can see these three images. They're just it's a multi-layered tile engine, and the tile engine has different rendering settings for it, right? So this is like a sunset rendering setting, this is foggy morning, and this one is like starry night, right? And it's all the same exact level, but with a different rendering applied to it. And the idea is we want this kind of like people think that you can either have this kind of like old school 2D tile map stuff, or you can have like the new school high definition 3D, and that there's nothing in between, but that's a complete lie, right? We can have 2.5D graphics. Not only that, but 2D graphics, 2.5D graphics, and 3D graphics, they're not like a time point in like in a linear evolution of the progression of graphics. They're actually on their own separate evolutionary path. A good analogy would be like a dolphin is just as evolved as a human being, right? They both have taken the same amount of time to improve themselves and evolve. It's just that, but they're different things, right? So same thing with this. The 2D graphics can evolve alongside 3D graphics. So let's go down here. So we see like this is the prototype for the auto tile set editor that we're going to work on, called PAINT5D. You're going to see that there's different pixel sizes or tile sizes in here, right? So there's this one size that's kind of a relatively big kind of square, and then we can pick different sizes as we go on. So here's this, size that's half of that. And then there's also sizes that are half of that and half of that until you get down to the smallest possible size. And this is the foundation of creating what I call fractal auto tiles. So with the auto tile, usually you have about 16 graphics that create one material. And that material, when you lay down tiles of that material, the tiles are self-aware of their neighbors and will select the correct subtile of that auto tile set in order to create kind of like this seamless geometry between tiles of the same material type. The problem with this kind of auto tiling is it's done with pixel art. So if you zoom into that pixel art, you get pixels, right? So how would you create something that auto tiles but is not pixels? Well, one way you could do it is do it in a fractal manner. So instead of having pixel art, where the pixels of an auto tile image are done in, well, pixels, you could replace those pixels with just more auto tiles. So take a piece of art done with pixels, and just say, instead of these being pixels, there are different auto tiles that are set down there. And so you can get this fractal manner of creating auto tile sets. And you can level it different, you can nest that kind of fractal thing different levels deep and use that to create these tiles that you can just zoom into at these ridiculous magnifications. And we're going to create something where we can zoom into the where we can kind of zoom into the tiles to an atomic level, right? So we can kind of zoom in until we can get to like one atom of a tile in terms of the scale. So that's what that's kind of what the goal is here. And let me kind of like make a note here. Hold on. I'm gonna make a note of who was chatting with me earlier, so that I can make friends with them and message them later, since I am kind of a small stream here. Grayson Dexman. Okay, so what else do I want to talk about here? I think that's all I want to talk about. Let's try to get to coding, but if you have any questions, I will try to answer them. But just a lot of things running around in my head right now. And also, we are not on 75, are we? We are on 76, and is this part 8? Is this part 9? So we are on part 9. So this is actually video number 76. We're on part 9. So let me change that really quick. Okay, cool. Okay, so let's get to this. And yeah, today was kind of unmotivating because I had problems with my... And I have problems with my internet speed right now, and I'm kind of not feeling very good about that. But let's try to not get completely demoralized, and let's kind of get to it, right? Let's see. Okay, so right here, this camera is not going to be a tile-based camera like the old prototype I did. It is going to be a selection rectangle over the entire data set, and it's going to tell me, you know, what tiles I need to render. So if the rectangle is very small, it's going to be selecting less tiles, which means that those very few tiles are going to take up more of the screen. So a smaller rectangle means we're zooming in, and a larger rectangle means we're zooming out, because when we have a larger rectangle, it selects more tiles, and to crunch more tiles into the visible screen space, they all need to be smaller, right? So an example of that would be like if we cover our screen with grains of sand, right? We got a lot of little grains of sand, but they're all very small, right? So that would be your zoomed out. And if we have one gigantic boulder in the middle of our screen, being like one tile, right? That one boulder is so big that it takes up the whole screen, so that's kind of like you're zooming in. I don't know if that analogy makes sense. It's not the most coherent analogy, but this is kind of how the camera will work. And the bounds of the camera actually depend on the zoom factor, I believe, of the camera. Let me think about that for a second. Or not the zoom factor, but the tile size, or does it? Now, actually, the tile size should not affect how the camera moves. And I don't know if I may have decided something different when I coded this, but the camera really shouldn't be affected by the brush size. We don't want like the camera to like jitter and change position when the artist selects a different brush. So we'll have to remember that as we code this. And all we want to do is execute the functions that are bound to the keyboard, and then just test that the camera is where we think it's going to be. And we're going to have to actually seed the camera position to put it somewhere, so that we can kind of like move it around and see how it reacts. So I think the first thing we could do is we could create like a test table here. So we'll do like a, how are we going to do this? So let's make a U32 array, and let's call it table of unit test code. And in this table, I don't know, rows, it's number of tests multiplied by test elements. And then we have to initialize it with some data. And I'm thinking the initial input needs to be a rectangle size. So the first test, we'll just keep the rectangle size dead simple. It's just at, the rectangle is at 0x, it's just at like this zeroed out position in the upper left corner. So this is x0, this is x1, y0, y1. So we have this rectangle that's defined by upper and lower bounds. And then we want to kind of move the camera on x and y. So for that, we won't actually move it anywhere. We'll just say move it nowhere on both the x and y. And then there's an expected output of another, what are the end dimensions of this camera, right? So the camera bounds encodes the size as well as the position of the camera, right? So we're going to take these initial camera bounds, we're going to set them, then we're going to move the camera using an X and a Y, and then we're going to see what the resulting output, how has moving the camera transformed the camera. Now this is a little big here to where we're kind of going over our border here. So what we're going to do is we're going to get kind of ugly here, and that's not too ugly, right? So we have the starting camera. So this is starting camera, and it's not really the bounds, it's both the position and the bounds. So we could say position and bounds. Translate, and then this is the ending camera position and bounds, right? So we can make a little note here that tab equals position and bounds, like that. Just because we kind of like made up this random acronym on the fly. And for this first test, it's pretty simple, right? Now, let's do kind of like 4 or 3 basic tests. Let's do 3, because 3 is kind of an easy cluster here. And let's say we translate it over 1 on the x, like this. And if we translate it 1 over on the x bounds are going to change. So the x bounds are now going to be like this, right? Instead of 0, they're going to be like this. Now, if we do the same thing on the y bounds, then we're going to put a 1 here on the y. And that's going to move it down on the y, because the upper left is our origin for a graphical origin. And the x bounds won't change, but the y bounds will change. So this is like your most basic kind of test, where, you know, this absolutely should work. If this doesn't work, we have like a major problem in our code. And then we'll do kind of like more complicated tests after this, right? So this first test, just dead simple test. So we could do @vid IID 0076, and the time is 0 hours 55 minutes, or it's about 56 minutes now, 56 minutes and 0 seconds. So the first 3 tests are dead simple, right? So the first 3 tests we're going to put in this table are going to be dead simple tests. I usually refer to dead simple tests like this as smoke tests. These are smoke tests because we're doing things very simple. We expect these tests to pass, and we don't want to write more complicated test logic until we can get these basic tests working first. And also, because we have all this stuff that's going to fail, all these compile time compilation failures, we don't want to add any more complicated tests than these very basic tests first, just because we've written a lot of code without seeing if it compiles yet. So we don't want to make very hard to comprehend tests until we can make sure that our test runners for all of these tests are working properly. So right here, instead of having a runtime error now, we're going to call this, we're going to do AAC 2020 to-do manager, and we're going to say vital. This is a vital to-do now. And this means it's not going to crash on compile time. It's rather going to crash if I say that vital to-dos should crash. And that'll give us, because now we have kind of something in place. Now we actually have to write a test runner for this. So to write a test runner, we're going to say for I equals, or actually we use ti for test index, equals 0. And then ti is less than or equal to the max test index. So we could do that, or we could say mti, max test index, and then ti++. Okay. And every time we're in here, we have to kind of grab the base offset to get the data. So the base offset equals the test index multiplied by the stride. And the stride is going to be the test elements. Like how many elements per test are there? Now once we have this base offset, we're going to get the initial x0, and that equals the table of unit test code, the base offset, plus 0, right? And we have 4 elements in this rectangle, so it's these values here, like this. So the x lower and upper bounds, the y lower and upper bounds, and these all have to point to different things in that array. So we'll just do it like this. This is the order in which I pack them. X is first, then Y is 0, 1, 0, 1. Okay. We also need kind of a macro here. So what we could do is we could just, rather than use a macro, we could kind of hard code it. But then we have to hard code it here as well. We'll get magic numbers kind of all over the place, and I don't really want that. So what we're going to do is we're just going to glue some macros up at the top and bottom of these tests and say number of unit tests, number of tests, and there are 3 tests currently. and elements, test elements, I guess, yeah, or number of test elements. And the number of test elements right here is, well, we got 4, we got another 4, and then we got 2, right? So 8, 9, and 10. Then at the bottom, we'll undefine these, right? So right after we get out of this function, we'll kind of undef these things. And then we want to use this verbatim in where we're declaring this array of stuff. So number of tests, and then number of test elements, right? And then right here, we'll times by number of test elements. This is getting unruly, so we're going to kind of do this. Right, so we're going to open that up a little bit. Right, so the table of unit test code, this is how big it is. We want to make sure that these are defines. We want to absolutely make sure that we're not creating a VLA, a variable length array, in our C code, because those are just horrible. Okay, cool. So that looks good. This is what's right here is called a variable initializer, or a struct initializer, or a initializer list is probably the most correct term for this thing right here. It's an initializer list. It's a list of values to populate this variable here. Okay, so we have the x's and y's for the initial values. We're going to need something for the next 2 values. And then we're going to need something else for those last 2 values. So let's change the numbers first. So 4, then 5, and then 6, 7, 8, and 9. And we're going to call this, we'll call it, instead of calling it initial, and let's call this in, right? So this is what goes in. This is what comes out, and this is also an input. This is an input, but it's a translation. So we could say tran ix like that, and I think what I usually do is like this, ix and iy. So translation x, translation x. Right, so this is the X and Y translation. So we'll make a commentary there about it. We also have to declare these somewhere. Right, we have a lot of variables we need to declare. So let's create like a variable declaration section here. And this is my way of making sure I know where the comments are supposed to be. Like, sometimes when you comment the start of a piece of code, you don't know, like this comment is kind of disembodied. Like it starts to become detached from what we were actually talking about. And so a good way, if it has a video commentary ID, we can kind of figure out what it applied to. But if we absolutely want to know what comment applies to what code, we can kind of do this. And that way we know when the comment ends and when it begins. So we have left justified, then right justified. I'm going to get back to... I've done this many times, so I know what this is. So I'm going to get back to just listening to music and coding, because it takes a long time when I explain things. So I want to kind of speed up the process. So I'm going to continue listening to music, but if I find anything vital to explain, I'll kind of keep on explaining. But right now, let's listen to more music. Alright, this is also something that's important to say. Sometimes people say numbering your variables is a bad idea, right? We have this variable called VP1, there's also a VP0, and there's a VPC, and they're all viewports. The thing is sometimes when you want your data to be as regular as possible, coming up with different fanciful names for things just makes it harder. You know, there's no way that I can make a decent sized variable name that's called offscreen/source tile bitmap data viewport, right? Like, there's no way I can make kind of a ruly name for that. The names are always going to get like really long and unruly. So viewport 1 is basically our camera, right? So we'll make a note of this to say, you know, say that, right? That, you know, viewport 1 is basically our camera. So let's just say, let's take a timestamp here and say @vid_iid, and the video is 0076, and the time is 1 hour, 10 minutes, and 16 seconds. Yeah, so this VP1, which is right here, P5D VP1, that is literally our camera. And these three coordinates here define where that camera is within a tree. So this tree right here, there's a 512 by 512 texture that stores all of our variables, and to get to the camera, we have to select this subcell here, which is 128 by 128 pixels. Then we have to further subdivide those 128 by 128 pixels into 16 more cells, and it says it's PAINT5D. PAINT5D is system number 1, so we're going to select this cell right here, and then some of the pixels in this 32 by 32 pixel region are encoding viewport number 1 right here. So we could also make a note that, you know, VP1 slash this is our viewport number 1, and then we can have an explanation of what that is. So VP1 basically means camera viewport. This is the camera variables controlled by Josh when he is editing tiles in PAINT5D editor. Alright, so that's what that is. I just wanted to make a note of that, and let's keep on listening to music. talk about what data pixels are. Data pixels are literally pixels on a texture, and they're going to encode some sort of data. In this case, that data is tile values. So the camera actually is zooming over this bitmap, but the bitmap is encoding tile values, which is kind of weird. But if you want to make more sense of it, you can think of each pixel as a tile, and the camera is the selection area over that bitmap that stores these tile values. So for this, what are data pixels? We're going to actually create like a little hashtag here and create like a little section name here. So what are data pixels? And then what we can do is we can go into our documentation of like little hashtag things, and we're just going to write, hey, well, what are those? What are data pixels? And you'll notice that I have underscores in front of this. We might also want to be able to find it if someone doesn't use underscores, so let's just do like, what are data pixels right here. And we're going to re-describe it one more time and say that data pixels are pixels on a texture or bitmap data array that encode some other type of information. So the data is packed into a pixel. The pixel bits actually don't mean RGBA. They could, for example, mean mouse X and mouse Y, right? They could mean anything, or they could mean the value of a tile. Very often used. Yes, how's it going? Oh, you got another Kevy.
Yeah.
Congratulations.
I stole it from my coworker because it was dying under her care, and also you can tell it needs to be repotted because it just slides right out.
Congratulations for being CPS of plants. Could you get me some water because I've been drinking too much caffeine?
And PPS.
PPS? What's that?
Think about it.
Oh, Plant Protective Services. Got it.
Yes, and PPS.
Okay. Good job.
Yeah. You
Good
want
job.
water?
Yes, please. Please.
Is that full of water or caffeine?
No, that's caffeine. Could you please get me some water?
Oh, you don't want to get rid of that caffeine?
This is my 1 cup of coffee. I am keeping it over here. I just need water, please.
Oh, you sound like you've had 1 cup of coffee.
Okay, so anyways, the value of a tile. Very often when I encode a pixel value, I mean, you know, the... Here, we're going to put another timestamp in here and re-explain this since we just kind of got interrupted. So at vid IID, so we're at 0076, and the time is 1 hour, 23 minutes, and 45 seconds. Okay, so when I mean data pixel, I mean a pixel that is encoding some other type of information besides RGBA, right? We're just using the pixels to encode some type of binary information. So data pixels are pixels on a texture or bitmap data array that encode some other type of information. Though the data is packed into a pixel, the pixel bits actually don't mean RGBA. They could, for example, mean mouse X and mouse Y. Let's put a little dash there so that is a little bit easier to read. Or they could mean value of a tile, and this is very often used. I very often do that. So when we see this translation IX, translation IY to move the camera, we're moving the camera in terms of data pixels. So it's a very important distinction to make. Now it's not quite... now for the camera movement here, it's not just data pixels, it's because it's not just going over the raw bitmap, it's actually going over a level of abstraction on top of that. But roughly, it's in terms of data pixels. So we have to think about... conceptually, this camera is going over a 256 by 256 bitmap rather than the actual data, which is encoded in a 512 by 512. And that's kind of confusing. But at vid IID 0076... time is hours, 25 minutes, and 40 seconds. So let's go over what does the data actually look like. Or, thank you very much.
It's full. It's full. It's full.
So what does the data look like? Where is the camera moving over? That is a very bad hashtag statement, but let's talk about where is the camera moving over. 1 hour, 26 minutes, and let's say 15 seconds. So where is the camera moving over? I'm gonna make a little section for that over here. But let's look at Tau Depot's data. So, actually not Tau Depot. Let's look at PAINT5D's data. So we have like this weird data structure on top of a 512 by 512 bitmap, which is how we're partitioning the data pixels to represent certain tiles. The smallest tile value is on tile layer 0, and there's 128 of them. Yeah, there's 128 of these. So the actual camera should be going over like this 128 by 128 map, basically. So the camera it's not quite in data pixels because it's not going over the exact data view. It's going over an abstraction of this, which should be tied to this 128 by 128 bounds here. What the artist actually sees is they see this big tile design on the top left, another big tile design on the top right, a bottom left, and a bottom right tile. And these 4 tiles are used to create a complete 16 tile auto tile set, but they're auto-generated from these 4. So the artist only needs to create this upper corner, and this upper corner, and these lower corners. And then from that, we'll take like the middle pixels of what they designed to create the touching everything auto tile, and then to create the kind of like touching top and bottom tile, we'll kind of like take pixels from like here, and we want to calculate the touching left and right tile, we'll kind of take pixels from here and here, right? And we'll kind of cut this up to auto generate the different auto tiles that we need. The reason we're going to do it like this is because a lot of times when artists are making auto tiles, they have a lot of redundant things they do. We want to eliminate all of that redundancy. Anything that's very redundant, we don't want to encode in the actual data, because then we're just wasting that data. We should just compute it on the fly, if that's the case. So we kind of see that even though like this thing can be like any size, right? Because we can zoom in and out of it. This is what the artist sees. But as far as the selection rectangle isn't going to be over this 512 by 512 region. It's going to be over a 128 by 128 region, now that I can kind of see this here. So what we're going to do is make some note of that right here. So where is the camera moving over, right? And let's just take this right here, just take this part of the diagram. And just paste it in here for reference. Oh, we forgot to take this part. Okay, so this is part of diagram. So this is part of a diagram called diagram P5D main. So we'll make a note of what this is from. Scene in file, and so the file this is from is the PAINT5D data file. Alright, so we'll make a note of that. Now, we shouldn't actually keep the full thing here, just because it's going to be different on different people's computers, so this is where it is for everyone. And we can see that the smallest tile is a collection of 128 by 128 tiles. Thus, the camera when zoomed out to the maximum outward zoom should be 128 by 128 units in size. These units are in data pixels. And see, and then we can say, see this section, right? What are data pixels? This is important. This is important to know. And we didn't do a very good job at, oh, also we need a timestamp here. So at vid IID, 1 hour, 31 minutes, and 22 seconds. So let's explain this one more time. The actual camera is going to be bounded to a 128 by 128 region because the smallest tiles, the tiles that there are the most of, is a 128 by 128 region, right? So we took this little section of a diagram and pasted it in here, but the full diagram can be found here. It's actually over here on my screen. We have a 512 by 512 bitmap encoding all of the different tile values for an auto tile set. And this is just how we're partitioning the raw data. But when we think about how the artist actually sees this data, they're actually seeing this. And so this is one tile with multiple different layers with different tile sizes. So this is one sub-auto tile, or offset subtile. And the smallest tiles that you can paint inside of this region are there's 128 by 128 of them, right? So as labeled right here. So this is actually how the data itself is partitioned. And this section right here would be the first layer of tiles that is overlaying over here. Or technically it could be any one. This could be any one of these 4 things here, right? Because we have 4 of these big rectangles. It could be any one of these. So technically, this little diagram here could be applying to here, 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 or here, right? So diagram to left could be, so this diagram to the left could actually be this thing, or it could be this thing, or it could be this thing over here, or it could be this thing right over here. So it could be a lot of different things. So I just want to make sure that, you know, you get the idea that this could be a lot of different things. So at vid IID 0076, and the time is, you know, 1 hour, 33 minutes, and 40 seconds. So when you see this little thing right here, right, so this diagram to the left could be any 4 of the quadrants. So this is the actual data partitioning of the actual data pixels, but this is actually what the artist sees. So this data here on my right monitor could represent this, 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 or this that the artist is seeing in their viewport. Okay, cool. So I've explained that pretty well. I mean, not the best, but it's enough that I'll understand what it means. So I guess that's the most important thing. And let's just keep on coding now that we know what those bounds are. Okay, let's explain this one more time about why the camera bounds are 127 by 127. You can find it also commented here, and you can check out these diagrams. Okay, so though the camera is moving over the data that encodes the tiles, so the data that encodes the tiles, when I talk about that, I'm talking about, where is, yeah, this thing right here. I'm talking about this 512 by 512 section. Oh, no, that's not correct. Can we close this? That's not the data I'm talking about. Not here. Oh, wait, it's actually up here. So the data that encodes the tiles, this is a 512 by 512 bitmap. It's partitioned in different ways to encode all the tile values, and the camera kind of moves over this data, but not quite. And the camera kind of moves over what the artist actually sees in their viewport. They see these different tiles, these 4 gigantic tiles that make up one auto tile set. The camera kind of is moving over this, and it's kind of moving over this abstraction, but not quite either one of those. It's actually moving over 128 by 128 region, kind of over here. And this 128 by 128 region represents the smallest tile size that fits into one of these areas here. So that makes things kind of confusing. And I also see that I'm kind of wrong with my math again. So I've explained this for the 3rd time, and now I kind of realize that 128 by 128 isn't quite right, because that's just one quadrant, and we want the artist to be able to see everything, don't we? So really what we want them to be looking at is something in... it's actually like a 128... plus 128 minus 1, right? Because the first tile value is 0. Man, I keep on screwing up here. So let's make a note here. So this 128, this kind of is looking at... Let's make a little diagram right here. So here's this little diagram here. Let's try to make a smaller one. And say, like, let's just try to recreate this. Alright, so we have kind of this kind of thing here. I was hoping that yeah, so it's good that I'm explaining things multiple times, because it's kind of like helping me make sure that what I'm saying is actually true, and sometimes it turns out not to be, which sucks. So let's take this and kind of split this up into these quadrants. Not being very efficient about this. Let's actually put a little dash here instead of a plus. Can we actually put like a bar here as well? Right, because this is one tile. Where's this one tile? Is that how I want to play this game? We have enough room where we could, so why not? So... So this size here, the size here, that you're seeing here is client area width. This is actually the client area width. Or it is the VP1 width in pixels, right? And it's the same thing for the height, but I'm not going to diagram that just because I think from the context you should kind of understand that the width and the height are equal to each other, so we don't actually have to diagram that out. So when we're looking at this here, this, one of these 128s by 128s is kind of looking at this thing here. So this is a little update. right? So we kind of updated this. This video ID is we've kind of changed things around a little bit. But right, since this is 128 by 128 here, right? So this 128 here, it's also 128 here. And so we can take these little notations here, and let's just call this let's call this hashtag top left subtile. Actually, that looks kind of ugly, doesn't it? Let's do it at top left subtile. Let's do that. That looks good. Let's kind of get these all centered in here. Actually, what we can do is, since we're kind of cutting and pasting, let's do it like this so everything is kind of nicely aligned. So at first I thought the bounds were 127 by 127, and let's do it at vid IID here. At vid IID 01 hours 46 minutes 47 minutes 47, god damn it, 47 minutes and 10 seconds. Correction, bounds are actually 128 plus 128 minus 1, not 128 minus 1. Alright, so here's a correction. The bounds are actually 128 plus 128 minus 1 for the camera, because this is what the artist should be able to see when they zoom all the way out. And for the smallest, most granular tiles, it's a 128 by 128 partition right here. And so if we zoom into one of these 128 by 128 partitions, we get this, okay? And there's 4 of them, right? So if we stack those 128s by 128s, we get a 128 plus 128 minus 1. So that should be 511, right? No, that should be 255. So 128 plus 128 minus 1 should be 255. Let's see what that is. Yeah, 255, okay. So when we're looking at the bounds here, we might want to make a note that, you know, that this right here, let's just do something like this. Say this is 255. This is kind of like odd, right? And let's cut this through here, and then hopefully we can kind of see this 255 belongs to this whole thing. Maybe what we could do is kind of like make this bold, like that, to help kind of see that it's kind of cutting through more stuff. I don't know. But also we're documenting it here in the in this video, so hopefully that also helps with knowing what we're talking about here. Okay, cool. So that was my mistake. And let's go back to where we're documenting this. So not our notes file, but in our PAINT5D data, if we go back down to where we're trying to make these constants, I already changed it, 128 by 128, 128 plus 128 minus 1, and that's the, these maximums are maximum indices. This is also a minimum indice. So the x0 and x1, y0, y1. So those are the bounds of the camera. So this is actually what we need, and I keep on screwing it up. Let's get back to the music, and I'll stop the music if I need to explain something again. Okay, let's get into why I gave some weird names right here. In case you're looking at this and you're like, what the heck did I do over here? Like, why is this so odd? So inputs and outputs versus expected and actual. I was just confusing these definitions with each other. Like, is the output, is that the expected value or the actual value? And I was kind of I was interlacing these meanings in a weird way, where I wasn't being consistent with what I meant. So what I did was I decided we need to be more consistent with what our variable names mean so that we don't get confused in the code. Because we were getting confused in the code. The inputs, that's easy, because the expected inputs and the expected outputs are exactly the same. For the outputs are going to be our actual values, and then we want an expected output here. So expected, this is the expected output, and these are the actual outputs, which are the actual values. The actual versus expected, this is actual versus expected, but it's also the outputs. But these here, expected, they're expected outputs, but they're not the actual outputs of the function. This is what, these values here are what should be in our test tables here, like right here. So what we want to make a note of is say that, you know, that this part is like in input, right? These are our input variables right here. And over here is our translation variables right here. And then over here at this little ending point, it's the expecteds. These are the, you know, expected x's and the expected y's. So we want to make a note of what we're looking at here. And we kind of screwed that up. So let's just put these little notes there and then change around what's going on here. So we got the inputs, and these are not out. These are the expected outputs, right? So expected outputs. Let's make a note of that. These are the expected outputs because they're hard coded into a table. They can't actually be our expected. They can't actually be the actual outputs. Seeding the initial camera. So we're going to set the initial camera here. We're going to set the initial camera with these values. We're going to run a translation command using these values, and then these are the expected outputs that we're expecting to have, right? Okay, so now that we've kind of noted that, we can get back to the music. Okay, let's talk about this for a second. My commentary on 127 by 127 for the bounds of the camera for PAINT5D were incorrect. The bounds are actually 0 to 255, or rather a 256 by 256 section here. So we can see this. I marked this as 255. That should actually be 256, right? Because we're going to take 256 and minus 1 for the coordinate range, but the actual thickness of this edge is 256, right? Okay, so now that we've made that change, let's talk about where that is in the code. Since we have some commentary about that. So here's where this is in the code. Let's make a little video marker for this. So at vid_iid is 2 hours, 13 minutes, and 20 seconds. So originally, the bounds for manipulating a rectangle were bounded into a 512 by 512 section. However, for the actual PAINT5D camera rectangle, we're actually bounded into a smaller 256 by 256 bounds. And if you want to see the commentary for that, it's right here. We need a smaller kind of hashtag. So let's say P5D bounding comment. No, let's just call it P5D bounding, and hopefully that'll be unique enough. So we created all these synonymous sections here. And so yeah, you can check out this diagram here, which will explain how we bound the camera rectangle. And then over here for this C comment, we'll say, you know, hey, see P5D bounding in the hashtag commentary if you want kind of the diagrams that are going to go along with that. So right here, we're going to say error, VP1 cam bounds are tighter, right? And that's kind of vague, but we have this bigger commentary right here to explain exactly what we mean about that. And if the camera bounds kind of like fail this test, right? This is a tighter test than this first test here. If it fails, we're going to immediately trigger an error, and then we'll kind of print off, well, what are the camera bounds again, right? Or do we want to do an error, or do we want to actually do a print off, right? Because we already have this failed unit test thing here. Let's not kind of duplicate that code. So let's take this and kind of paste this up here. And this is just another condition for triggering a unit test failure. So we'll say this right here will have these other conditions for failing. And then we'll just say, you know, failed unit test equals 1, right? So another case for failing the unit test. Instead of this being cam bounds are tighter, we're going to say log cam bounds are tighter. And then use a null pointer here, because there's no other information that's going to go along with this. And then if we failed the unit test, we'll still print off what those values are. So check against expected output. So pretty beefy section here. But I think we have the final test for this. We'll add more. Right now we only have like these 4 test cases. We need more, but we'll do those later, once we have all the other tests kind of fleshed out and have the basic frameworks for them. Okay, so that's it. Let's keep on listening to music. Alright, so hold on here. I like this. I like the stuff that I don't like this music, but anything that actually has lyrics, I'm going to remove because it interrupts my thought process. Coding is a very right side of the brain kind of thing. We want to get rid of that. We don't want to. If we're drawing, lyrics are okay because it uses the left side of the brain. But lyrics are fighting for the brain processing power that I need to use. So tuck and roll, MMX, armored armadillo stage. We're going to delete that from our list of music. So let's go here. Let's go to the E drive. Non-vital, just for fun. Music. And then we have Y for year, 2020. And then like this playlist of a whole bunch of stuff. I don't know which disc it's from. We're probably still in here because it's Armored Armadillo, and that's Mega Man X1. So, tuck and rolled Armored Armadillo stage. Okay, so yeah, we're gonna delete that. Cancel. It can't be opened because this is opened. So we're going to close this. We're going to be pretty strict about this. So just like you, MMX. So we're going to delete this. This is the next one. So let's play this. And yeah, lyrics are banned. Okay, you're also banned. So just like you, MMX, Tunnel Rhino. Also banned. Delete. Okay. Let's just keep going. Okay, that looks good. So, Sigma Opus. We're gonna just go through everything in here. Okay, let's go through this one. If there's any lyrics, nixing them. Okay, let's delete that. Let's just, since we're gonna have to reload the folder, let's just go through everything really quick and make sure we don't have any songs that have lyrics. Which is kind of tedious, but I do not, yeah. So if you're familiar with marketing, there's this term called sticky. Like when something's mentally sticky. And lyrics are good for creating things that are mentally sticky. And that's why techno is not as popular as songs with lyrics, because there's no ability to look up a song from its lyrics if it doesn't have any words, right? So I think that, popularity is not always a good metric of how good some music is. It's just sometimes music without words is less marketable. But music with words is just, I hate music with words. I mean, there's some stuff I like, but most music with words, I do not like it. But yeah, we're just gonna go through this. Okay, and we're just gonna find anything that has lyrics. Mix. Okay. Okay. not, just because it's more like it's a sound clip more than a lyrical thing. It's kind of on the edge, but it also isn't. It sounds like it's in Japanese, and I don't understand it. So if I don't understand it, that's okay. 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 God, this is a lot of stuff. Okay, so let's just, I do like Vile soundtrack, so we might just play this folder, after I see if there's any lyrics. Okay. Yep. We can accept that. It has a heavy metal style, but all the lyrical stuff is just, it's not actual lyrics, it's just using your voice to make sounds, which is okay. Okay. Okay, too lyrical. Deleting. Okay, two more. Okay, and one more. And then we'll just play this folder. It seems with that song there's like one lyric at the very end of the song. We'll allow that. Okay, so let's open this up and let's play this folder. Okay, cool. And let's keep on coding. Okay, let's explain some of the things we cut and paste so we can change the IDs on some of these comments. So the weird names right here, we've already explained this before in the other section, but let's change this to 2 hours, 38 minutes. And, okay, 39 minutes, I guess. And 10 seconds. There. So the weird names is because we're just confusing input and output with expected and actual. So we just name them a little bit stranger so that we don't interlace those meanings. So the output in the actual value is this stuff, and then the expected values are right here. So this is what we're actually going to get as the outputs of the function calls, and these are the values that we're actually expecting that are extracted from the arrays of test, the test array, right? Okay, so the other thing we need to re-explain, since we have a commentary here. So we're at 2 minutes, and let's say 40 minutes, 2 hours, 40 minutes, and 0 seconds, I guess. Good enough. Viewport 1 basically means the viewport that the artist is looking through. It is our camera viewport, right? The camera that Josh is actually looking at. It's just a rectangle, that's all it is, but when we talk about VP1, the specific rectangle, its usage is the camera viewport. There's another viewport, VPC, which is the client area viewport. So we could squash the output viewport with VPC by remapping VPC to something that doesn't cover the whole client area. And the reason for that is if we want some type of UI that's not overlaid over the editor, we might want like a, say, a command prompt. We could partition the screen using VPC to put a command prompt rectangle somewhere. So VPC will be like this client area viewport for the actual data that we're looking at. Therefore, we might need another thing called like VPC, VPP maybe, viewport prompt, command prompt, or something like that. I don't know. But yeah, that's just what these commentaries are about. So let's keep on going. You notice we just copied and pasted the test from the translation, and now we're applying it to the zoom, and we're kind of like refactoring things. So really dead simple stuff, right? We don't have to... Sometimes the bottleneck in your test code is actually the typing speed. A lot of times the bottleneck in your code can be typing speed. Don't listen to people who say the bottleneck is never your typing speed. It very often is. Okay, let's keep going. Okay, before we get too far in this stream, we're at like 3 hours, so that would mean like 30 push-ups and 30 other things as well. So let's get that done and over with before that number gets way too high. So let's look at our push-up screen. Let's reset this. So this is going to be reset to 0. And the stream sessions for today, we don't know what we're doing, right? We're in the middle of this stream right now. So ... Let's just get that done and over with. The integer ID of this stream is 76. Is that true? Let's make sure that's true. I mean, hopefully it's true, because otherwise we're in some trouble here. Yeah, yeah, we're on 76. Cool, that's good. So yeah, let's just get these push-ups done. And also audio output. Yeah. All right, so I'll be right back. I just got to do all my push-ups and whatnot.
And shall not find it, and they shall desire to die, and death shall fly from them.
Whew, okay. 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 Whew. Okay, let's go and heat up our coffee and get some more water. Since we're in like a little break, might as well get all those things done at the same time here. Okay. Okay, where the... Okay, so let's get back to it. Hold on, let me move stuff around. Yeah, so we're just writing more unit test code. Nothing fancy here. Nothing really crazy in terms of what needs to be done here. So yeah, let's keep on doing it.
My name is Thomas Light. I am the researcher who designed and built Mega Man X.
Okay, let's talk about what's going on here. For our testing for toggling of tiles, we're going to need a way to set a value into the tile map using the brush, because the toggle tile command, the output of it is going to vary depending on what tile is already there. So we're going to need to create a put into brush command and a put use brush command. This could be put using brush, might make more sense. Or put use brush state. Or put, we could say put state into brush, right? I don't know what we want to call it, but this one loads the see tile data location with initial value. Yes, that is correct. And we need this, so this one is yes, this goes up to load brush with all of its state. Right, that's what this is doing right here. Load brush with all of its state. And like toggle tile, but is an override rather than a toggle. That's what this is. What else is going on here? Let's get rid of that. That's going to cause some problems. PAINT5D put I don't like put into brush. Put use brush. I don't know if these are the command names I want to use. Put, and then I guess what we're doing is brush state is kind of what we're doing. And this one is put use brush, right? So put and use brush, so it's going to use the user's brush rather than using all of these variables, right? And that means we need to make sure that this command works properly. And we don't have it anywhere because this command really is going to be used for... Actually, it will kind of... Right now, this command's just going to be a helper method for the put using the brush state, right? Yeah, because this is going to require fetching all those values. It's going to be kind of... Yeah, we're going to need this. Put brush state. So right over here, instead of put into brush, we'll say brush state. And then push put use brush. Yeah, that's kind of awkwardly irregular. Instead of brush state, we could say using. And if we do that, then brush state and using brush, they kind of match in terms of their length, which I really like. So we got the brush state and using brush. So we'll go with that. So using brush and then brush state. Okay, cool. So let's make a note of what's going on here. So at vid IID, 4 hours, 42 minutes, and we'll say 12 seconds. Or actually, no, we're not going to say that because that's the wrong timestamp. We need to actually take 0076 here, the recording ID, and the time, 4 hours, 42 minutes, and how about 35 seconds? It's a little bit long. Well, now it's not. Okay, so what's going on here? AAC 2020 PAINT5D toggle tile is wired into the keyboard. But for unit testing, we need to use put brush state, which loads the brush state, and use put using brush, which is like toggle tile, but always overwrites. So in this section, we label this pattern breaker, right? Because this section is all of the things that are bound to the keyboard. But these two functions here, let's actually take them. So we want to put the brush state and take like all this stuff here. Right? We want to take all these guys to put the brush state. And we also then want to put using the brush. So I also want to put using the brush state. So there's nothing in here. This is actually void. Okay, and if we use those two commands, we can use them needed. So these are needed to test this thing right here. So we could say needed to test toggle tile. Right, and so we have this kind of really awkward nesting here. So this stuff is needed to test the toggle tile call. We'll just do that for now. So the put brush state and put using brush is going to be needed to test our PAINT5D toggle tile command. So this itself is actually bound to the keyboard, and these things here are not bound to the keyboard. Not bound to keyboard input. So this section right here is actually not bound to the keyboard input, and this is the pattern breaking thing. And I decided it kind of belongs here in a way. It might be a weird place to put it. Maybe we'll move it around later. But right now I want to keep a reference of it right here, so that when I'm writing the test code for this, right, because we're trying to test everything that is bound to the keyboard, and now we realize, hey, we gotta make these new commands. And the question is, well, where are we gonna put these commands? So, because technically these commands are commands for, they're not bound to. So let's just make a new section of tests, I think. That might be the easiest way to handle this. So everything is, right, so now we have a little bit more loose ends than I wanted. But let's, if we go all the way up, geez, we have a lot of, let's try to, yeah, there's a lot of test code here. Like, a lot of it's very redundant, but it's all here. So these are programmatic controls, and then these are the, sorry, that was the end of the section, wasn't it? User controls are down here, and then shouldn't that state that these are pragmatic controls then above? Hold on. So let's scroll down to the bottom of this user controls thing. Oh boy, there's just a lot of scrolling around here. We should make a little stamp. Because, boy, this is way too... To traverse through here, we need to, I'm going to say, I'm going to call this a unit test, I'm going to call this a unit test big block, because we just need, we need some way to kind of quickly kind of see what's here. 1, 2, 3, 4, 5. So we're going to call it unit test big block. The user controls were above. No, that's not quite right, is that? The pragmatic controls are below. Nope, okay, the pragmatic controls are below. It looks like I kind of put these in the order that I wrote them. That's fine. But we want to just label all these big section dividers with unit test big block or whatever, just because, right, this is a ridiculous amount of, like, code to just scroll through, right? We just got a lot of stuff, a lot of subdivisions. Like, this is ridiculous, right? So prog controls above. We're going to take this 1, 2, 3, 4, 5. I don't know if that was a good amount, but 1, 2, 3, 4. Yeah, that's good. Okay, so we got this unit test big block, and so now we can kind of scroll through these sections, but we're not through everything because user controls are above. So we're going to go up above all of these user control tests that we've been writing, and we're going to add another little stamp to let us kind of scroll through that as well, because this is ridiculous, right? This is like, whoa, what the heck, man? And a lot of this is cutting and pasting. So imagine if I had to write all this out by hand without cutting and pasting, it would take me forever. And that is kind of redundant, where it's like, you know, 1, 2, 3, 4, 5, 2, 3, 4, 5. Okay, I see. So the user controls are below. Now, what's above here then? What is this stuff then? System data restore. It looks like this is for unit test, and then this is a system data restore. Okay, that's fine. So what we're gonna do is say we're gonna make another like unit test block. We'll create 2 of these. And then this is gonna be above, and this is gonna be below. And they're not going to be user controls, they're going to be, I'm going to call them like, I don't know what we're going to call them. I guess we call them test controls. Let's call them test controls. Sure, why not? And these are just going to be... this is going to be a block of unit tests that's literally just created for... because we need some type of tests. We need these control... We need to... How am I going to say this? These controls are pragmatic controls, but they only exist because I need them to effectively test my unit test code. So it's like, they're kind of pragmatic controls, they're kind of user controls, they're kind of like... They're user controls, but they're kind of, I don't know. It feels like an intermediate category. I guess technically they are user controls, but they're not wired into the user interface. And they're not quite pragmatic control. They are pragmatic controls. I don't know. So let's not worry about that, but put Brushstate. And this is a test code for this, right? So let's open up this block for the Brushstate, for putting the Brushstate. And all we should be able to do is do unit test prog controls. So this is going to be like a PAINT5D UTC for unit test code. This is going to be all lowercase. Yeah, so that's all going to be lowercase. And then over here, we're going to take this and make a test for this as well. Okay. And we have to change the namespace in front of there. So it's going to be PAINT5D unit test code right here. We're going to take this and we're going to shove it right here. So unit test code put Usingbrush, unit test code Brushstate, and I believe Brushstate is actually, it needs to say put Brushstate, right? So we're testing these commands here. And for this section, it looks like unit test prog controls. We're going to take this here, and we're going to create a, how do we indent that? We indented it at kind of at the same level. It's kind of weird. Maybe we shouldn't have. I almost think it should have been like this, maybe. That way we can make a distinction between the subfunctions of this test category, I think. Okay, so in here, for the pragmatic controls test, we're going to call these. We're going to use some forward declarations. So I believe you can just do extern void Then the function we're going to call, and we just call it with void, so we don't call it with anything. And we're kind of running out of room here, so let's see if we can throw it. Yeah, that's good. So, actually, no, this is actually literally void, but the call is not. So, let's take this, move this around, and this has a commentary. This does not have a commentary. Okay, cool. So, we'll take this, and then we'll do a forward declaration for the other function, and then call it as well. So we put the brush state, and then we also want to call this thing called put using brush, and write the test code for that. So, okay, now, as far as where we need to actually insert these functions, I don't know. We'll figure that out as we look at the categories above. But for now, we're just going to do like a error write test code, and then we'll put this right here, bam, like that. We'll copy paste that in there. Okay, so now we got to figure out, well, where are these guys going to go, right? So let's go up and figure out where these are going to go. Now, this is the actual implementation code we're looking at. Ooh, before we do that, we almost screwed ourselves. So let's go back down here for a second. We have prog controls. We have user controls. And right here, we're going to say test controls. Kind. These are controls that may fit into the prog control or the user controls category. But the main thing about them is that they have been created in order to effectively test our user controls section, thus must be called before and after. I got that wrong. After prog controls and before user controls, right? So let's make a @vid IID. And the time is 4 hours, 56 minutes, and 15 seconds. So right here, we created a new section called test controls. And these are controls that may fit into the prog controls or the user controls category. But the main thing about them is that they have been created in order to effectively test our user controls section. Thus, must be called after prog controls section and before user controls. So we're going to throw this in the middle. So right now we see, okay, we got the system backup, and then we have running the tests. And in the middle of this, we're going to call the new test controls. So we have prog controls, test controls, and user controls. Test controls is kind of a weird name, but that's what we're going to call them. Now, eventually we might want to wire these test controls into the controls for the editor, but forever and ever and ever, they're always going to be in this category because that was their initial purpose. So let's make a note of that, you know. So here's our prog controls, and just make a note of this. So @vid IID, and the time is 4 hours, 57 minutes, and 50 seconds. Even if these eventually get wired into our user controls, they will forever stay in the test controls category, because that is what they were initially created for. And also, I'm lazy and don't see much utility to refactoring my unit test code for a non-code breaking change. Okay, so basically, we're saying that, and we'll change this again. We're going to change the timestamp here. 4 hours, 59 minutes. And let's go with 10 seconds. Okay, so. Oh, hold on. So this is not prog controls anymore. Did we kind of duplicate that name? So we got prog controls. This is obviously the wrong name, but I'm guessing we just cut and pasted here. Yeah, so here's the prog controls, right? So we kind of duplicated that. This should be test controls. Okay, let's make sure that's correctly spelled and everything. Okay, cool. So now we have that. Okay, so let's change the timestamp again. 4 hours, 59 minutes, and we'll go with 45 seconds. Okay. So, even if these eventually get wired into our user controls, they will forever... Let me just say that again. God damn it. Okay, let's try not to... Okay, we're at 5... God. This is getting ridiculous. 5 hours, exactly. Even if these eventually get wired into our user controls, they will forever stay in the test controls category, because that is what they were initially created for. And also, I'm lazy and don't see much utility to refactoring my unit test code for non-code breaking changes. Let's make that plural. Okay. So what am I talking about in this block? I'm talking about the fact that this put Brushstate and put Usingbrush, eventually maybe we will want that wired into the user control. So Josh can use keyboard controls to set this or set this. Even if we do that in the future, we're going to say, well, they're grandfathered into this section because the original reason that we created these was to be able to effectively test the unit test code for the user controls. So these are test controls because their original reason for being, their original reason for existing is to help us test the user controls. Okay, so that's why that is like that. And we're just going to keep it like that. Okay, so now let's go up to where we're going to put this stuff, because I have no clue where we're going to put this. But it's definitely not going to be in the unit test section. It's definitely going to be below here. This says keyboard handler. We know it's not a keyboard handler function. It may eventually be, but right now it's not wired to the keyboard. So tau uniform controller functions. So we got PAINT5D put is being called here somehow. A lot of stuff. Ooh, a lot of crazy stuff. Toggle tile. Technically that's wired into the... Let's not worry about it. So delta mutate. These are... Wait a second. Delta mutate. These are wired in the keyboard handler. Are we in the keyboard handler section? Okay, keyboard input. Oh, these are keyboard input. Okay, so it's not key in. They're literally key in functions. We'll just say, you know, something like functions wired into keyboard. We'll just make another section here, right? So This is kind of weird. Functions wired into keyboard. Let's just... Oh, hey! Let's, what are you getting? What are you doing? Food. So... yeah, let's kind of name this... Now that we kind of see what that is, we're going to just double name this section here to not get so confused. Yeah, because, yeah, these are all wired into the keyboard. That's, you know, the original reason for this section was they are manipulating this stuff, but they're also kind of like wired into the keyboard. So we want to just double label this section here. And then make sure, is this on the outside of both sections? Let's just go over here. Yeah, it's on the outside of both sections. So the new commands we made are not wired into the keyboard. So we shouldn't we should not put the new functions in this section. Oh, I see. Oh, I see. The ultimate bribe, huh? Alright, I see what's going on here. Okay, well, if I'm going to take a break, then I'm also going to do my push-ups. So we're at like 5 hours. So I don't know how long this bribe is going to take. I'm going to say, let's do a 20-minute break, I think, right? That's enough for push-ups, then going upstairs, figuring out what kind of food I want from Red Lobster, and then coming back up. And it's a Ask Me Anything. Yeah, I mean, you could just... this is a Ask Me Anything now. Can't you just ask me what I want down here? Oh, I see. The answer to that is a dangerous one. Like if you want the actual psychology for why that is, it's not a good answer. And a lot of things in psychology, social psychology, are kind of like the reasons for why the brain works the way they do are not always politically correct. And I'm actually not supposed to get into politics on this channel, but sometimes social psychology is not on the side of whatever is currently politically correct. And why people may be attractive to other people is actually totally taboo psychology in terms of like the actual reasons. Like if you want to look at the actual reasons, it's not genetics. It's not genetics. Well, I mean, genetics can be part of it, right? Because if you're healthy, makeup is used to kind of mimic good genetics in some ways. But it's not just that. But now that you said it, I gotta say it. A lot of people will model what the optimum female or male specimen is usually based on what your mother or father look like, or what your most important female or male like role model looked like. So right, so when you're young, you're very impressionable and you get imprinted, and so you're going to take whatever you originally experienced as male and female, and those are going to be like, you're going to get imprinted with that. And then if you're attracted to a male or a female, you want the optimum specimen, so you're going to look at what is imprint. They close in... Well, you shouldn't ask me in-depth questions. So anyways, I have to add these... God damn it. Okay, so let's just make a note here, because we're going to get real lost if we don't save our spot here. So hold on, I got to create these functions. And I don't even know where to put them yet, so... Okay, so I gotta do... let's do 30 push-ups and 30 crunches and 30 whatevers. So, let's go to our break screen. And, no, let's go to our push-up screen. And we gotta do 30 of everything, because we're almost at 6 hours. Okay, well, if that's the case, I can't come in, because there's no way I'm doing 30 push-ups, 30 crunches, 30, etc. So, I don't know if you could just get me like crab legs, or lobster tail, shrimp, non-breaded, any of those, broccoli or asparagus. Okay, so yeah, that's what I need. Anyways, okay, well, if that's the case, well, now I'm already on the push-up. Okay, well, now I'm interrupted, so I might as well kind of do my push-ups, because, you know, let's not add more interruption than we need. So push-ups are going to interrupt us anyway, so we should try to batch all the interruptions together. So we need 30 of each, I think, and that'll save us for a little while before we need to do more. So 30 of each, and then we'll get back to coding. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 23. I can call this 24. 25. 26. 27. 28. 29. 30. Okay, so so let's change these numbers now. So we're going to change these to 60. We're also going to go upstairs, get some more water. That should take us like 5 minutes, I think. Yeah, so let's go to break screen. And this is going to take like 5 minutes. Okay, 5 minutes. I'll be back. Getting water, maybe microwaving my coffee. Okay, hey, I see somebody else kind of showed up while I was getting my coffee. You can ask me anything. Just took a break, I did my push-ups, refilled my coffee. Well, didn't refill it because I'm only allowed 1 cup a day, but I kind of like reheated it, put some milk in. So I usually don't restart the stream until that timer runs out. And that's because if anybody is like waiting for that timer to end, I want to make sure that they have the same amount of time as I do, right? So like if I set that timer for 10 minutes, I want to guarantee 10 minutes to anyone. So I can't really go into any of the code details right now. But if you ask me a specific question in chat, I can answer. Otherwise, you got 1 minute to wait, and then we'll kind of go over what I'm doing. But what I can do for you is I can put my technical demos into the chat for you. You can check those out. The current engine I'm working on is going to take all of those technical demos and merge them into a final engine design. So all those things in there, a lot of them are proofs of concepts for an engine design. The engine concept is fractal auto-tiling using 2.5 dimensional graphics. That includes like a lot of normal map blending and a lot of nesting data structures. The data structures, though, are going to be encoded in MIP-map-like data structures. So there's not going to be, what do you call it? We can't encode like a linked list style node tree on the heap. Oh, there we go. So we can't encode like a linked list style node tree on the heap and then get it over to the GPU. We need a very strict data format where we can just take a linear chunk of data and push it up to the GPU. So the data structures need to be very tightly packed, even though the data structures are representing a very tree-like structure. So one way you can do that is use a MIP map-like structure. Another way you could do that is if you look at the algorithm for I think it's called a hash sort. A hash sort is basically like a tree sort, but done with all of the data in an array. So you can look at one of those. Check the time. I resetted the timer. Yeah. Anyways, we lost one. Okay, so anyways. Are we good? Yeah, we're good. Okay. So let's keep on going here and figure out where these new functions need to go. Okay, so put Usingbrush and put Brushstate. And we have them kind of right here for reference. So let's just close this. We don't need this. We know that we're going to create those functions. Pixel backup, we might need to address that later. But yeah, we're not going to be in the functions that are wired into the keyboard. So we're going to be, I guess, up here somewhere. Put Usingbrush and put Usingbrushstate. So they kind of depend on these get and put functions in a way. Right, and this is the put and get. And this is quark map put and get. Okay, so I think the logical place for these is going to be inserted right in this section here. Right, well, hold on. Between the quark map put and get stuff and the stuff that's wired into the keyboard. And that actually makes sense, right? Because these test controls are intermediary between the pragmatic controls and the user controls that are wired in the keyboard. So it does make sense that it would go here. So created to help unit test user controls. And these are originally not wired into keyboard. So we're gonna create 2 section dividers here. We've been creating double section dividers, so we might as well keep up with that pattern of 2 section dividers. The time of day is 9 p.m. Oh, that time. I thought you were talking about the stream time or something. Yes, okay, I will do that. God damn it, I just got up, so now I have to get back down and go do that. Okay, so let's do that once we create these sections for where this code needs to go and put like little air macros or air compiler directives in here. So put Brushstate and put Usingbrush. It doesn't really matter what order they're in. We'll just say, you know, void put Brushstate. We're going to need a lot of parameters here, and then we'll fill that out there. Okay, so this thing is void in both output and inputs. Okay, and we'll make a little divider line, dash line I1 x64. And then we need a divider line up here at the top so that it's obvious that this category here has more than one function. So when we're putting the Brushstate in here, we got a lot of stuff we need to put in here. So we're using these highly shorthand variables because of how we're calling it in the test, and we're running out of room in our test tables. So these are going to be our variables that we're going to work with. So we could describe these a little bit better. To do description, right? It doesn't hurt to describe them again, right? Because we have the room to give them some brief descriptions. So we might as well make use of that empty space there. But yeah, we need to get, hold on, so air, finish this function. So we need to finish this function, and we need to finish this function as well. So we're going to take this, we're going to paste that there, and we'll take this and we'll paste that there. Now that's kind of stubbed in, ready for us, but we gotta, we have to take another break to do our drugs, because we have serious problems. After 25, you get a permanent debuff, and I am 35, so I'm fucked. The worst thing for your health is not eating bad food or lacking exercise. The worst thing for your health is getting old, because once you get old enough, you die. Okay, so anyways, let's just take another quick break to do our drugs. So, you know what? Let's make a new break screen. Hold on, I'll be right back. Okay, let's keep on writing these functions. There's nothing that I really need to describe here, so I'm just going to get to it and listen to music. You can still ask me anything, that's fine.
Dude, get this. Mega Man X and Mario Kart put together, shablam.
What the hell are you talking about, mate?
Alright, second.
Just imagining it, man.
Okay, so anything that has lyrics in it is getting nuked. So let's close this for a second, and let's check our music for a second. Disc 5 bonus. Was this what we were looking at?
Dude, get this.
Don't care. Delete. Yep. Move that to the recycle bin. Anything that has lyrics, delete it. Okay, hold on.
Give me zero.
Okay, now there's a few sound clips. We'll let that one slide. Okay, that's good. Okay, let's just play the whole album, since we've kind of deleted all the songs that have lyrics. Okay, let's talk about why... Oh, hold on. Let's change this to 45 minutes and 0 seconds. Okay, why are these inputs right here 32-bit signed integers when the range is all that can fit within a unsigned 8-bit integer, right? Well, the reason for that is eventually they're going to need to be upcasted here to an unsigned 32-bit integer. Well, I guess they're now being downcasted. But the point is, you know, why not make them wider types here so that we have a little bit more range checking ability in the body of the function here. That's kind of why we're going to make these int32s when the range for all of these should be between 0 to 255. The range is actually smaller than that, but that's the range we're going to use. Now, another thing we might want to check for is check for integer overflow. And so there is actually a value that needs to be int 16, now that I think of it. So let's take all these things here. The local, actually no, the local is between 0 and 255 as well. Okay, so we want to assert that if we do an unsigned 8-bit integer cast of any of these values, that they're going to be equal to the version that does not have a cast. So we see these are int32s. We're going to assert that this comparison here just works. Now, because of how this works, I think we might be able to cast to 8-bit and then cast back, and that'll work. But I'm a little bit worried about that. So to make sure that this works correctly, I think I don't know what we should do. I mean, the compiler will complain at us if this doesn't work. And then I think if we cast this and then we upcast, let's just make sure. Let's go look at, like, what happens when you downcast and upcast. Well, downcast and then upcast. Well, let's just do an assert here. Let's check our logic. Let's assert that if we take something above 255, so if we take something like this and we downcast it and then we upcast it to 32, we're going to expect that this is less than or equal to, right? Make sure and a downcast and then upcast truncates the U32 to only 8 set bits max. We want to make sure that this is that we are understanding the C language correctly. So we'll put this in here to make sure that we understand that correctly. And then all we got to do is downcast and then upcast, right? So if we downcast and then upcast to I32, then this value here should be equal to this truncated version here, right? So we're checking for integer overflow here, right? Bounds check for integer overflow. This is obviously complete overkill, But it's good to be a little bit paranoid than to not be. Okay, so now that we've done all of that, put all brush state. So this is the main logic that we're going for in this function, where we're going to put the brush state. So we'll make a little section divider for this, and then put all of the brush state that we need to put. So a lot of this is going to be very redundant because we're just going to go through all 7 of these things. So let's just make a little notation here. I believe we have 7 elements of data. So let's just do a, how do we want to do this? I guess we could kind of, there we go. So we should have 7 elements. And I know we kind of did a little checksum here. So we're in other places where we have room to kind of add that little checksum, we probably should. Doesn't look like we can add the description here. We don't have quite enough room for that detailed description name. But yeah, let's just add checksums everywhere, just to make sure, hey, is everything accounted for here? A lot of this is very redundant, but that's okay. Code is redundant a lot of the time. Alright, so everything should kind of come out to 7, right? So this should come out to 7, that should come out to 7, that should come out to 7, like just all of this should be 7s, right? And that looks kind of ugly. We should probably fix that up. We're obviously getting a little bit too designy here, but oh well. Okay, so 7, 7, and 7. Then over here, we might as well just keep this kind of pattern here, where we're just kind of like counting over on this right margin how many things we have. Okay, so now we know we have 7 things. Let's just take this, paste it 7 times. 2, 3, 4, 5, 6, and 7, right? Very redundant kind of stuff here. And we just need to go through each one of these. In fact, what we could do, if we capitalize these, then we wouldn't have to, well, whatever, let's not do that. Let's actually kind of bite the bullet on this one and just do, we can take these asserts here and put them over here for reference for what we're doing. So this is TQ, right? So TQ is right here. The next thing is going to be this TE. Then we're going to have the TL. Then we need the LX. Okay. Then we need the LY, the AD, and the TV for the tile value. Okay, so once we have all those, we need to say, oh, this is TV now. This is AD. This one's LY. For layer Y, or not layer Y, local Y. This is local X. This is the tile layer. This is the tile exponent, and this is the tile quadrant. Okay, so now that we have that, we want to make sure that, well, everything's accounted for. So we're going to color these and make sure, ooh, not like that. We're going to color each one of these and make sure that right here these 2 things line up, or color each time we color these, right? So that lines up, that lines up. Make sure we don't make any stupid kind of transposition type errors. Yeah, so all that's accounted for. Right? It's all accounted for in the function signature, right? This is, it's a very big function, but it's very redundant, right? So it's not hard, it's just like, here's a whole bunch of crap we have to write, right? Okay, so that looks good. It's going to take an int32, and let's just do this tile quadrant. This is tile exponent. This is tile layer. Yep. Okay. This is the local tile location X. This is local tile location Y. This is the offset index. And this one is the tile value. And so it's kind of weird that the tile value is kind of separated from all of these things. But the reason that tile value is down here is because of the way we use the get input commands in the order that they appear in the get input commands. That's why tile value is down there. We just want to keep a very consistent ordering between things, so it is kind of weird being there, but we're going to keep that ordering just because that's the ordering where it is everywhere else. It doesn't make much sense in the context of putting the brush state, but we're just keeping a consistent ordering between all of the other APIs. So we could make a note that, at y here. Then we could kind of break this open and make a note of that, right? Or I don't know. Is the last parameter because Alright, so this is the parameter order of the function AAC 2020 PAINT5D put, which takes these parameters. So if we look at the parameters PAINT5D put, right, so tile quadrant, tile exponent, tile layer, local TX, local TY, and then the value to put, right? So since PAINT5D put has that parameter order, see tile quadrant, exponent, layer, TX, TY, dex, and val, we're going to keep that same ordering in this command for putting the brush state, just to keep kind of consistency between everything here. So let's just make a notation of that. So we can make a note, at vid IID, and the video integer ID is 5 hours, 57 minutes, and 20 seconds. And let's go over that. That is not the integer ID. That is the timestamp. The vid IID is 0076. Okay. The time is 5 hours, 57 minutes, 20 seconds. Okay, cool. So let's talk about this one more time. 5 hours, 57 minutes, and let's go with 55 seconds. So the reason tile value is the last parameter, even though there's these other tile variables right up here. The reason why they're not grouped together is because this command's signature is based off of the signature of AAC 2020 PAINT5D put. So if we look at this and we go backwards in a backwards direction, we'll see these exact same 7 parameters, 1, 2, 3, 4, 5, 6, 7, in this exact order, right? So we just want to make sure that we keep this order. So we might also want to make a note of parameter order identical to same param order as AAC 2020 paint. Let's just call it PAINT5D put, and it's called Brushstate, I believe, if we remember that correctly. So let's make a little note here as well. Okay, yeah. And then we can also make a notation here. And the time is 5... Let's do 6 hours. 6 hours, 00 minutes, and 00 seconds, and then we'll just wait. Okay, so we can make a note of the parameter order of this function being the same parameter order as this function here. Okay. Let's wait 20 more seconds. We can count the parameters again. 1, 2, 3, 4, 5, 6, 7. Yep, that's the same parameter order. 52, 53. We're just going to wait. And then we're going to end the stream after we describe this, since the food is here and we've done enough push-ups. Okay, the parameter order here is the same as the function put Brushstate. So this PAINT5D put was the original function we wrote, and then when we wrote put Brushstate, we also made the function signature take the same exact parameters, but it takes these shorthand parameters because the unit test code creates this test table for all of this stuff. So we just made these parameters short, which is kind of a bad idea because it fractionates our variable namespace. So we also put the long-handed versions of all of the variables on the left, right over here on the right. So that's it for this function. We also need to get on to this function. We have a little air macro for that, so that shouldn't be too hard. But we're at 6 hours, and if we look at our push-ups, we've done 60 push-ups, so we've done just enough as far as I'm concerned. So we're going to go over here. We're going to say that this stream was basically 6 hours. And we're going to end the stream, and we'll be back after food is done. And we'll change the integer ID of the stream and all that good stuff. But we're going to eat some food, take a break. Also, my drugs are making me feel really fucking sick, so... Okay, so we will be back later. See ya. If I can stop this. There we go.